about vegetables, talk to Lysette Seed. Hello everyone, welcome to Around the VegTable. So I'm Lysette Lacambra and your host for this program. In today's episode, we are joined by Ed Moerman. Ed, hello Ed.
Hello, good morning or good afternoon.
Good morning. Who serves as a process developer in Agronomical Development, R&D Microbiology at Koppert, while also a work group member at the Koppert Foundation. So he will share the non-target effects of chemical pesticides on beneficial organisms. But before I hand over the virtual floor to Ed, let me briefly introduce him. Ed's journey in horticulture began during his youth, growing up in the greenhouses of his family in the Netherlands. He completed his bachelor's in horticulture in 1980 and subsequently served as a government advisor to greenhouse vegetable growers from 1980 to 1988. In 1988, Ed started his long career at Koppert. His role involves overseeing global sales support, logistics, and quality control. Additionally, he contributes to developing sustainable farming methods and supports the Koppert Foundation. In his work, he enjoys highlighting nature's power and biodiversity, understanding the benefits of a systematic approach to fostering healthy plant growth is very rewarding for him. He values practical measurements to gain insights and improve processes. Sharing knowledge for everyone, like for example today, benefit is a top priority for Ed as he strives to contribute to a healthier world for future generations. So thank you, Ed, for accepting our invitation as a resource speaker for this relevant topic. How's the weather in the Netherlands?
Well, a bit chilly this morning, but we expect a bit more sunshine this afternoon.
I
we
still
really
remember.
can feel spring coming now.
Yes, yeah, I hope that I can get some of your cold weather here in Thailand. It's getting hot in Thailand. Now I'm giving the virtual floor to you, Ed, to present our topic for today.
Thank you very much for your introduction, Lysette. Really honored to be on this platform and to share some of our knowledge about integrated pest management, and specifically today about the non-target effects of the chemical pesticides that we sometimes need to use. So I will present in a nutshell what we know and how we handle this, and also lead you through an app that you can find on our website, where you can find loads of information, really fact-based information about this topic. So integrated pest management is a hot topic nowadays, and you can find information anywhere. And I just took a small quote from the European Union definition of IPM, which says that it is aiming to have the least possible disruption and encourage natural pest control mechanisms. And then EU gives a number of IPM principles. When I say IPM, I mean integrated pest management. Of course, as you may understand now, one of those principles is really on this topic, but there are three of the principles that have influence, or where both East-West Seeds and any seed company and Koppert play a role. The principle one is using the seeds that of cultivars that are resilient against pests and diseases as much as possible. Principle 4 of IPM is using all kind of methods that are non-chemical, preferred above the chemical methods to keep the crop healthy. And then about the pesticides, they should be specific. So just acting on the pest or the disease that we want to manage, and not having unwanted side effects on our own health but also on non-target organisms. And that's the topic of today, because there are many beneficial organisms around the farm, on the farm, that can really help to keep your crop healthy. And that's typically the role, the responsibility of the advisor and the grower or farmer to take the right decisions here. And this seminar is meant to help making such decisions. So what kind of non-target organisms are we talking about? As I said, there is a lot of free help in nature. And also East-West Seeds has a very nice training module on this topic, which can be reached through the link, and that really gives a nice overview of all kind of helpful organisms in nature. Can be insects, can be mites, can be fungi. So we want to allow them in the crop. We don't want to kill them because they are our free helpers. Next to that, there are a number of biocontrol organisms that the farmer can introduce in the crop, which can be natural enemies, let's say any insect or mite that can, or other type of insects that can control pests, but also it can be beneficial bacteria or fungi. There are also quite a few of them that can be purchased as a product and introduced in the crop. And we're talking about entomopathogenic nematodes, very tiny worms that can kill a wide range of insects in a natural way without harming the environment. The ones that we buy, we also don't want to kill. So it's also important to be aware of any action that you take in the crop. Well, I will now slowly build up a table to give some more explanation of the topic of the side effects on the non-target organisms. And in the top green line, you can see the three types of organisms that I distinguish. The natural enemies, so the insects or the mites, the microorganisms in the second column, and the last one are the pollinators. Not typical crop health, but still very important for crop yield. If we kill the pollinators that arrive from nature and stop them doing their work, it will really affect the yield of the plants. Then in the first column, I will distinguish some different modes of contact between the pesticide or the pesticide residue, and also related to the application method, and explain what is happening with the different categories. So the first and most intensive, maybe most intensive confrontation is when the grower sprays a chemical onto the plant, when natural enemies are at work there. That's what we call a topical spray, a direct spray, or you can call it a toxic shower. That can, for natural enemies, cause mortality, so they just can be killed, but it also can reduce the effect. Without directly killing them, it can reduce the predation or the egg laying, and then the effect of the natural enemies is seriously affected. Similar effects can happen with beneficial microorganisms if they are sprayed directly on the plant or in the soil even. Also with the pollinators, they can suffer. Some chemicals can really directly kill bumblebees or pollinating flies, or they can cause a repellent effect, so the crop stinks and the pollinator does not want to go there, and that can have the effect of reduced pollination and also can result in lower yield or poorer quality. The second way in which the beneficial organisms can be affected can be by dry residue. So some chemicals, if they're sprayed today and they dry in a couple of hours, they can still be harmful days or even weeks after the moment of application, just because the residue penetrates in the leaf or just stays there and it's not washed off by the rain. In that way, it can also have similar effects compared to the direct spray. So don't always think when the crop is dry, it's safe. some chemicals are really not safe, and some even remain harmful for the beneficial insects particularly, and mites, 2-3 months after application. So they're really the bad guys, but we will show some examples later on. Then there can be another way of confrontation. That's if the residue of the pesticide is inside the plant tissue. Sometimes chemicals are applied as a drench. So the plants take it up with their roots and it comes into the plant tissue, especially when insects or mites are sucking from the plants. They also ingest the chemical, and the pest itself can be controlled by that. That's the target. That's what the grower intends to achieve. But sometimes when predatory mites, for example, eat a pest that has eaten from a leaf with inside a residue, then you get a kind of food chain where the toxic residue builds up in the natural enemy and finally can lead to mortality or reduced egg laying or predation. So that's a kind of a hidden danger. You don't see the effect directly. It takes some time to build up, but it can definitely have effect. For the microorganisms, I could not think about examples where it worked in the same way. For pollinators, it is. We really had big struggles with residues of some neonicotinoids applied as a drench, ending up in the nectar or the pollen and affecting in that way the pollinators. Not repelling, but they take it back to their hive, they feed it to their larvae, and finally the larvae are killed or do not develop fully. So there are sometimes tricky routes that pesticides can take and arrive at the beneficial organisms. The last way of application is the tank mix. I mean, that's not applicable to natural enemies because you don't put them in a spray tank, but the microorganisms are applied, dissolved in water, and then applied via the normal spray equipment onto the plant. Sometimes farmers or growers, they want to do things in one work, so they like to put the beneficial fungi or nematodes in the same spray tank as the chemical. That's not always advisable. Sometimes it's no problem, but sometimes it can also have effect. For pollinators, this is not the case. So these are different routes that chemicals can take to have effect on the natural enemies or the beneficial microorganisms or the pollinators. Well, there is a lot of information known about this topic, and we as Koppert, I mean the effective application of biological control at farmers is our bread and butter. So we don't want that to be disturbed by chemicals. And we put a lot of effort in organizing all the information about this topic in our side effects database, which is available to the public. I'll first show you now some screenshots of the interface of this database, and then we will try to go live into the database and show you some examples how to see and to learn how it works. Oh, by the way, you see the hyperlink. This is where you can find this database. I mean, it's freely accessible. It has now about 20,000 records of combinations of chemical active ingredients and all kinds of different natural enemies and beneficial microorganisms. And it comes from many different sources. We do a lot of trials ourselves with these combinations to understand the interaction. Some we outsource to a dedicated lab. There's a lot of scientific publications available about this topic. So whenever we lay our hands on these publications and we trust the information, we put it in the database as well. Our company has, I think, 400 advisors worldwide in the field, having daily contact with clients, and they acquire a lot of experiences with this topic. There is in our profession, the IOBC, the International Organization of Biological Control, a special working group focusing on this topic. They have developed protocols and they arranged also a lot of information around the topic. There are many research institutes, well, that reflects in the scientific publications often. There are other sources, there are like other websites, and also the producers of pesticides, they have a lot of information about this topic, because if they want to apply for a registration of a new pesticide, they have to provide data about the non-target effects against some standard microorganisms and standard insects or pests or mites, which is part of the dossier, at least in the Netherlands, and also accessible. And we have one employee assisted with some others who's focusing to get all the information on the right place and make it understandable for our colleagues, but also for the growers, our clients, and anyone else who wants to know. If you go to the app, which we will do in a minute, you can select combinations of an agent. So that's how it's called here in the red area. So that's the pesticides, which can be searched either by trade name, so then you click the left button, or by active ingredients. It's always one of the two. Active ingredients are often appearing in many trade names, and we don't have all the trade names in the world in this database, as you can imagine. So if you cannot find the trade name, always look up the active ingredients. Then select the beneficial organism, so the non-target organism, something that you want to introduce in the crop, or something you have noticed in your crop and you are aware that this is very valuable one, you don't want to kill it. You can select this, and then we go to the green area, either by the Koppert product, but I imagine that those names are not known for everyone, but you can also switch to the Latin name or the scientific name of the organism that you want to better understand in its side effects. And then once you have made those choices, the results appear automatically. You can also make more choices at once, so you can create a kind of a table, I think, of maximum 7 different agents in combination with 7 different beneficial organisms. You will see a result table with all kinds of symbols, which we see here. It looks like this. So on the left, in the green square, you see the scientific name of Pesticides, which is a predatory mite against spider mites, followed by the next column, 3 different stages of which we have distinct information, in this case the egg, the nymph, and the adult. And also, that's a very important one, the persistence. So that means how long after spraying will it remain toxic for this particular organism. Well, I selected one of the worst one that we know, cypermethrin, and that is valid for all the synthetic pyrethroids, that group of chemicals. You see it in the last column. Then it says SP. That's the way of application. SP stands for spray. So if you spray cypermethrin on the plant, it will remain toxic for all the 3 stages mentioned, indicated by the 4 in the red circle. So we have 4 different categories, 1, 2, 3, 4. 1 is safe, 4 is very harmful, and 2 and 3 are intermediate. And then the last square of information says something about the persistence. If you spray cypermethrin, it remains 8 to 12 weeks toxic against Pesticides. So this is really bad news. That means if you spray this kind of materials, you will eradicate all the natural help from insects and mites for a long time. Well, then there is a legend which we will see on the next page, a bit bigger. I think it should appear now, where you see all the symbols, etc. explained. On the left top, I already explained the 4 categories. It's expressed in effect on the effectivity in 4 equal categories, as you can read here. And then the persistence can be indicated in days, and that's only for the bumblebees, for pollination. The persistence is normally indicated in weeks for all the other organisms. Well, for the bumblebees, there is a different scaling. When we place bumblebees, or same applies to honeybees, in a crop to pollinate, and the combination shows a circle. then everything is okay. If it's a triangle, you need to cover the hive for as long as the crop is wet. The arrow to the left is to remove the hive from the greenhouse, and the cross means it's incompatible. The right column specifies all the application methods, which are acronyms that express the way the pesticide is applied. So we saw SP, the fourth one from the bottom, spray, and we have talked about drench, DR, the first one, which is can be done often. Tank mix, we have spoken about, the second from the bottom. Those are the most common ways I think that pesticides are applied, also researched in their side effects. Well, this is the picture that we already saw on the previous slide, with a warning that some things really last very long. Now let's go live. I think Mark can switch now from the presentation to my laptop, where I have the side effects in view. Does it work, Mark, you think? Okay. So here you see the two interfaces that I showed. So we can select an agent. If I choose the active ingredients, I know that acetamiprid is a neonicotinoid, which is often used. So if I click it, it's selected, as simple as that. Then I go to the beneficial organism. Well, let's choose the bumblebees. That's Bombus terrestris. Well, it should appear, but it doesn't. Maybe I didn't select it, so that was my fault. And then automatically the table appears that says that, oh, for this one, it's a neonicotinoid, but a safe one. If you spray it, you just have to do nothing, and it is not persistent. So then you know, if you want to apply a chemical with acetamiprid in it, and you have bumblebees flying in your crop, it's no problem. So let's look at another one. I want to apply a very old one, benylate, benomyl. It's not allowed in the Netherlands anymore, but you will find also quite a few older chemicals, which still may be relevant for countries in Asia or in Africa or in Latin. So we decided just to leave them there, because it can still serve the people who are there. Maybe best to clear the filter first, then we start clean. So we choose benylate, and the beneficial organism, the Latin name Phytosylus. You see it has a very quick searching function. If I just type PHI, it selects Phytosylus, which starts with those three characters, but also another one, Ophira, where these three characters are a bit more further in the word. But I wanted to show this one. This is a bit of a weird combination. Generally, you can say insecticides or acaricides can be harmful to beneficial insects or mites, because it's the same type of organism, but sometimes it's also very selective, so then the beneficials don't suffer. And fungicides can be harmful to beneficial fungi as a general rule, but not always. So that's why you need this app to really know the details. But this is a kind of a special combination. Benylate is a fungicide, and we learned in the past that if you spray it, and even when you drench it to treat something in the root zone, Phytosylus, living in the leaves, eating spider mite there, is suffering. So that was the typical example of a systemic effect of a chemical going into the plant, arriving into the pest, into the spider mite, without any effect on the pest itself, but then it can affect the natural enemy. So in this way you can make all kind of combinations. With the buttons in the bottom you can open the legend like this, the one that I just showed. If you are in doubt about the meaning, there is some background information with the eye explaining how all this information has been generated and managed, or you can even contact Koppert apparently, and you can print the table showing the selections that you just did. So this is appreciated by many of our clients as a useful tool, and we still continue to maintain it and to extend it with new beneficial organisms or with new chemicals. So you can always go there when you want to find some information. Well, sometimes it can be a bit challenging when you are using this when the trade name is not in the list. So then find the active ingredients on the label and then use that as the entrance into the app. It can also be challenging if the chemical product has multiple actives. There are some combinations in the database, but not all. You can imagine that there are so many possibilities that it's an endless job to try them all, so we decided not to do that. We focus on products with single active ingredients, unless a product with multiple ingredients is used very often, then we also do trials with that product. And then it can also happen, of course, that the beneficial organism that you are worrying about is not in the list. Well, then what I do sometimes is a bit of extrapolation, but you have to be careful with that. I mean, one mite is not the same as another mite in its response. It can give an indication, but it's not really a fact-based answer. So be careful with that. So how can we really exert the least possible disruption to the agro ecosystem and encourage natural pest control, either from the surroundings or the environment or from what you obtain from a company or from whatever way? It's really important to make a plan, an IPM plan, and then try to list which pests and diseases are relevant in the crop I want to start growing now. Also, when do these normally appear? You can maybe make a kind of a calendar to have some indication when a problem appears. And then also think about how you can best monitor these pests and diseases and to record the observations to have a good record, also to learn later on how the crop health has been evolving. And then make a plan. What actions can be taken? Either to prevent the problem, can start with selecting a good variety, or to cure the problem if it's something that really will appear and cannot totally be prevented. There are a number of mechanical or natural measures that you can think about, like sticky traps or pheromone traps or netting, or you can do crop combinations that sometimes can be very valuable. There can be, apart from the free help from nature, there can be sometimes biological crop protection products locally available. I mean, East West Seeds and Koppert are working together in some countries, but not all. There is a website that you see now on the right, the bioprotection portal run by Kabi, that shows the available non-chemical products for many different problems in a long list of countries. So this may give some hints where you can find the biological solutions. The link to this is also in the presentations. And then if all those things do not help enough, then make sure that you know which compatible pesticides that are available in your place can be used in your situations. And then you can use the side effects app as a help to take the right decisions. This is what I wanted to explain you. Really thank you for your attention, and I'm sure there will be some questions. The presentation will be shared afterwards, and it is also recorded, I understood. So please come with your questions.
Thank you very much, Ed. Thank you so much, Ed, for sharing your expertise and the Koppert tool on the non-target effects of chemical pesticides. This was really relevant to our work as extension service providers, or even really people, colleagues who are also directly working with farmers. And even if, for us, we are also farmers in a way in some of some of our areas. And I hope our participants also see this as an essential tool in giving recommendations, especially on ensuring responsible use of pesticides. I see a lot of questions coming in, so I think we are ready to address some of the questions in the chat box first. Ed, first question from Aliyu. So from Aliyu in Nigeria, he was asking, is there available selective pesticide that control targeted pests without causing negative effects on the beneficial one? So So that's a question from Aliyu.
Yeah, there are definitely selective pesticides for different pests and diseases. I mean, we normally manage to make a concise plan for a crop with most of the pesticides that we need to kill the pest or diseases, or to manage that without harming the pest. But you really have to sit down for it and to make a good plan and to use the information available.
Thank you very much. And I think I go back to what you mentioned, that not just go straight to the pesticides, but you also have to think about more preventive actions in your farm. There's another question from Ramid in Ghana. So does organic pesticides such as plant extracts have any harmful effects on beneficial insects?
Well, some may have some effect. I mean, there are so many of those options that we haven't tested many of them. But I think in general, you can say they will not be as persistent as the bad chemicals. So if they are harmful, it will be just for a short while. So then you can think about how to best manage that. If you want to introduce natural enemies in your crop, then apply the organic products just before you introduce the beneficials, and not after, because then the dry residue normally is okay, but a spray, a shower with the material may have some risk. So then you better do it in the other way around.
Okay, so first apply the plant extracts before you apply your bioagents. There's another question from Ramid, continuation. Can we say it's better to drench systemic pesticides than to spray on the leaves to reduce the effects on flying beneficial insects such as bees?
Yeah, that's difficult to give a general answer on that. I mean, not all the pesticides are effective when applied as a drench. And also, when things are applied as a drench, I think the chance for the pest to build up resistance is higher. So I would not give that as a general recommendation.
Thank you very much, Ed. Is there any also a need to consider on the timing, like time of the day to spray?
Maybe a bit depending on the types of natural enemies that you have and their behavior in the crop. So that's difficult to generalize that. I think you better focus then on the moment, on the day of spraying that is most effective, that the chemical is most effective in order to have the best effect, and not to need to come back sooner.
Yeah, I think from what you mentioned, Ed, it's also very important for us to identify what beneficial organisms are present in our field. So if we don't apply products, for example, we need also to have that ability to identify those beneficial organisms in our own farm. Maybe another training or webinar in the coming months.
Yeah, I mean, we're happy to support that. Maybe nice to tell an example to illustrate this. In Spain, there is very intensive greenhouse industry where they had huge problems in the past with thrips and tuta absoluta, which were initially heavily sprayed with tough chemicals to control that. But then at the moment, we managed to develop biological systems that handled those pests. And initially, we had to work hard to control them with the beneficials, but it worked, and then the growers were happy. But then after some years, we saw that the beneficial insects that we needed to introduce, we could go slowly a bit down, and we noticed more and more natural enemies from around the greenhouse coming inside, supporting the system, because we omitted all the broad spectrum persistent chemicals that killed all those free guys, and that we really noticed that that supported the control.
Ed, you mentioned that you can also increase the population of the beneficial insects, and I think this is related to the question of Everest and Antuona. Could these non-target organisms, the beneficial ones, become harmful to their host or to the plants maybe as their population increases over time?
I think you can generally say those organisms which we label as natural enemies of pests or diseases, they are really depending on the pest. So if the pest goes down, the food source is diminishing, and then the development of those insects is also slowing down.
Mm-mm.
And also that's also a way that we select the beneficial organisms for production. I mean, they should never be able to form a problem by themselves. They depend on the pests.
Yeah, that's great to know. And also, that's also part of your research, right? On really looking at the long-term effect of this beneficial introduction to the field. There is one question from Fatika. What about using biological agents such as Beauveria bassiana to control Leptocoryza or Artorius pests? Can it have a bad effect on other insects, non-target organisms?
Yeah, well, there are a few. You can also find Beauveria in our side effect database, by the way. There are few soft-bodied, a few natural enemies with soft bodies that can be affected by Beauveria. So if you want to apply that, again, first apply the Beauveria and then introduce the natural enemies if you buy them somewhere.
Thank you, Ed. I hope that clears your question, Fatika. One question, Sylvia, before I go to you, I can combine from Gali and Sebastian. So, what deliberate effort can a farmer make to introduce more beneficial insects and pollinators on his farm?
Well, I think first, the first and best thing to do is to stop with the broad spectrum and persistent chemicals. And I already mentioned the synthetic pyrethroids. They are famous in the bad sense. Well, neonicotinoids are variable. You really have to make the right choice. Some of the old chemicals, the organophosphor compounds, which we don't have here anymore, but maybe in some of the countries of the attendants they will be there. They can be quite harmful, so check them on the side effect database. And then that's the way to minimize the damage. The way to attract natural enemies is, for example, by planting flowering crops around your farm or rows of flowering plants in between the crops. We have a nice project now with Lobularia in Spain, which attracts Aureus, which is a good natural enemy against thrips, and builds up the population that can act in the leek that is planted on the farm. So choosing the right flower mix can be very helpful in attracting the natural enemies.
Yeah, that's very good, and also it's a very practical way to attract beneficial insects. I think we can also work on that, Ed, on identifying the right ornamentals of flowering plants in different countries that we are working with. From Sylvie, what would be an easy way to demonstrate non-target effects to farmers without the use of digital tools?
It's a good question. I appreciate the question.
Yeah.
But I mean, if you see how much effort we already have to do to create a solid methodology to have the same results with the same combination every time, that really is hard and sort of scientific work, and you don't want to go to cut corners. I mean, when you do something simple and that shows that something is safe and maybe it isn't safe, you go the wrong way or the other way around. I mean,
Yeah.
really want to be a bit careful with answering this question, but I want to note it down and give it some extra thought, and maybe we can ever have an extra webinar about the topic.
Yeah, sure. We can discuss it more also, Ed, in as partners on how to develop that. From Ate Marilyn in the Philippines, app is interesting. Does the toxicity effect of active ingredient differs from a temperate to a tropical environment? And does the side effects reflected in the app based on a temperate field condition, or it applies to all insect species as indicated, whether in a temperate or tropical condition?
Yeah, that's a good question. I think you can read something about in the information button. I think much of it is based, well, either on when the trial is done in lab conditions. I mean, it's not related to a certain climate zone. When it's from field conditions, I think often it is, yeah, sort of from our Northwestern European conditions. And then you can say, like, persistence may sometimes be not as long if you're in a tropical climate with high temperature and high humidity, a lot of sunshine, where chemical residues break down quicker. So it needs some, sorry. The direct effect will be the same, yes, especially when there is a difference, it will be in the persistence. There may be 2 months, will be 6 weeks, for example, or 5 weeks. That's
Thank you very much.
Yeah. Also
Sorry,
makes a difference if the real situation is inside a greenhouse where the light is filtered and which will slow down the breakdown of the chemical, or if it's outside, then in the full light, then the breakdown of the pesticide residue will go quicker as well. So it's not a hard figure. It needs some sort of common sense to make the interpretation to the local situation.
Thank you very much, Ed. Just for the time management, we have still some questions, but I will select one. For those questions that we cannot answer at the moment, as Ed mentioned at the beginning, we will share to him the question and he can also answer it. And we will share it with you, all the answers on your email or even in our Facebook group. There's one question that I would like to maybe conclude this Q&A from Ghana. Does the quantity of pesticide use have high harmful effects on beneficial insects? And why do some pesticides have harmful effects on non-target organisms?
First is about the quantity.
Yeah.
Yeah, when we do tests, we always test, of course, the label rate and the label quantity, but also the double and half to see if there is a dose response effect. And sometimes you do see that more active ingredients has more effect in the bad way. So that, and also, yeah, the information you find in the app is always based on a single application. If there is a series of applications, like every week or so, then you can imagine that some chemicals, they can build up on the foliage and have more effect than just the single applications. But yeah, the number of options are endless that you can think of. We haven't tested that, so we test a single application, and yeah, it's all when the multiple applications are much more harmful. It really there's at this moment no way in the side effect app to express that. But that's where the importance of the consultant of the corporate advisor comes in, to give warnings when that's relevant. And the other question was
on
why it is, yeah.
Yes.
Yeah, there are so many sort of metabolic processes that are influenced by a chemical that is in contact with an insect, and some may influence the metabolism of the natural enemy, and some won't. And that's really, I mean, that also goes beyond my real knowledge to really explain that. And I'm sure that there's a lot of science behind it to understand, because also the chemical companies, they have to develop actives that do affect the pest, but not some natural enemies, they really must understand, and they do understand what's happening on a really, really small level. But that's beyond my expertise.
Thank you very much, Ed. I think we can also invite other experts to continue on that discussion. Thank you very much. Sorry for our participants who have questions. We will send the answers from Ed later on. So thank you so much, Ed, again, for this very important topic. And I hope that all our participants also will see this as very relevant to use in their field. So thank you, Vel, and thank you to our participants who stayed with us until the end. That's the end of our episode. Do you have any questions you would like to be answered in the future episodes, or topics that you would like to learn more about? Leave your questions or suggestions in the comment section, or contact our technical support hub members in your country. Stay tuned for the next episode of Around the VegTable. Curious about vegetables? Talk to Isvesid. Thank you very much.